MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on operational amplifier voltage regulation using IC 723. To design a low voltage variable regulator of 2 to 7 volts using IC 723. Design of the low voltage regulator is as shown here. Assume the output current as 1 milliamperes and input reference voltage as 7.5 volts. The V0 value lies between 2 to 7 volts for the design consideration. The figure shows the circuit diagram of voltage regulation using IC 723. Load regulation and line regulation are the two parameters for measurement. The output of load regulation and line regulation is as shown in the figure. Keep the output voltage constant and measure the current by gradually varying the input voltage, note down the readings and plot the graph. For load regulation, connect the load at the output terminal, keep the output voltage constant and gradually change the input voltage, measure and note down the current and voltage values. Repeat the process for several readings and plot the graph.
Dear students, today I am going to explain the experiment of voltage regulation. The aim of the experiment is I am going to check the IC 723 is working for the voltage regulator. So in that voltage regulator we have two things we have. So one is line regulation and another is load regulation. To do this experiment, the components required are one is DC regulated dual power supply, 3 multimeters. So these 3 multimeters, one multimeter I am using for the measurement of current and 2 multimeters that will be used for measuring the input and output voltage. 4 resistors, one is 100 ohm, 2.2K, 3.3K and 5K. This 2.2K and 5K that will be used based upon the design. So for this experiment I am going to design for 5 volt. If you want to design some 3 volt regulation, you can use different resistors based upon the design. Circuit board IC 723, this is a 14 pin IC. So from the left of the notch, this is a notch, from the left of the notch you need to count the pin numbers. Pin number 1, 2, 3, 4, 5, 6 and 7. So 8, 9, 10, 11, 12, 13 and 14. 1K pot. So this is a tuner to tune the voltage level. So these 3 connections that will be used in the circuit and the connecting wires. Now I am going to connect the voltage regulator circuit based upon the circuit diagram. Now I am taking the circuit board and IC 723. So now I am going to mount the IC to the circuit board. So based upon the circuit I am connecting. I am going to short the pin number 12 and 11. So pin number 12 and 11 I need to short. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This 12 and 11 I need to short. So this makes the short between 11 and 12th pin. Next 6th and 5th pin that will be shorted with the 2.2K. So now I am going to take 2.2K and made the short between pin number 5 and pin number 6. So this is 1, 2, 3, 4, 5, 5th and this is the 5th pin and 6th pin made it as a short. So this is the 6th pin. I made it as short. Now I am taking 5K and I need to connect that 5K to pin number 5 to ground. So this is pin number 5 and this is ground. I connect it to the pin number 5 and the ground. Now I am going to connect the pin 3.3 kilo ohm resistor to pin number 4 to pin number 10. So this is 1, 2, 3, 4. This is 4. Fourth pin to pin number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is pin number 10. So I am connecting here. Now I am taking the wire, positive wire, that will be connected to DC regulated power supply, positive, and that will be connected to pin number 12. 11 or 12 we are shorted, so anywhere we can give either 11 or 12. So I am going to give here, this is plus VCC, I am giving here. The negative voltage that will be given to ground. To ground. Pin number 7 I need to make to ground. Pin number 7. One, two, three, 4, 5, 6, 7. So this is pin number 7. Pin number 7 to ground. This is ground. Next I am going to connect 100 ohm to pin number 10 to pin number somewhere. So pin number 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is pin number 10. Pin number 10 to somewhere the point that will be in the circuit. Next I am going to connect the ammeter positive to the 100 ohm resistor. Positive to 100 ohm resistor, and the negative that will be connected somewhere in the circuit board, some point. I am connecting here. You take the pot, one terminal of the pot positive that will be connected to ammeter negative. So this is the ammeter negative will connect, and other two ports you made it as short by using a ground connection. So I am going to connect these two terminals to the ground here. Next I am going to connect the output voltage terminal positive of the output terminal that will be connected to pin number 10. The pin number 10 I am connecting. This is pin number 10. The negative of the terminal, output terminal to of the terminal to ground. For the voltage reference, I am taking another voltmeter. So another voltmeter positive, so that will be connected to the pin number 11 or pin number 12, because there is the input voltage we are given that terminal. Pin number 11 and 12 is shorted already, so I place this input to these two pins, either 11 or either pin number 12. Next, the negative end I am going to connect it to ground. This completes the circuit connection of voltage regulator by using an IC 723. Now I am going to switch on the DC regulated power supply. Here I am using 3 multimeters. This multimeter is used to measure the output voltage. This multimeter that will be used to measure the current, output current. So this multimeter that will be used to measure the input voltage is nothing but the reference voltage that will be given to the circuit by using DC dual power supply. Now I am going to increase the input value from the step size of 0.5. So I can know, before that we need to switch on this first. So this will be set to voltage of some 20 volt. This is an ammeter. I am going to switch on this to some 20 milliamp. So next I am going to switch on the voltage to some 20. Now I am going to increase the input voltage of 0.5. For the 0.5, my output voltage will be 0. The reference voltage will be 0.5. There is no deflections in the current. Next I am going to further increase this one to some 1. My output voltage will turns to 0.06. Okay, the current deflection will be 0.05. Input reference voltage will be 1.0. Next, further I increment it to 1.5. The output voltage will be 0.24. Reference input voltage will be 1.51. Like that we need to fill the table input voltage versus the output voltage. Further, in the step size of 0.5, I need to increment till the constant value will be appeared at the output terminal, output voltage. So now I am going to increase further. I will check for some values. I am going to check for 3.5. For the 3.5, my input reference voltage will be 3.5. My output voltage will be 1.42. Next I am going to increase further to some 5 volt. My input voltage will be 5.0. My output voltage will be 2.43. Further I will increment it to some 6.5. My input voltage will be 6.43. My output voltage will be 3.34. Further I incremented to some 7.5. My input voltage will be 7.41. My output voltage will be 3.99. Next I will further increment it to some 8.5. My input voltage will be 8.5. output voltage will be 4.69. Further I will increment it to some 9. Input voltage will be 9, but the output voltage will be 4.82 only. So I will further increase some to 10 to 12. You see there is no deflection in the output. You see I will increase further some 12.5 I will put, 12.6. There is no deflection in the output. So this will indicate the IC723 acts as a voltage regulator, that we call it as a line regulation. So take all the readings from 0 to 12.5. So you can find one curve, the voltage that will be gradually increased and it will comes to a constant at certain point, and there is no deflection from that point. The output voltage, there is no deflection from that point. So that gives a constant characteristic curve. This curve we call it as a voltage regulation curve, or this experiment is called as a voltage regulator experiment. Now I am going to show the line regulation, how to do the line regulation. Again I need to minimize all the values of the input. So further you increase the voltage to 11.25, because that will be based upon the design. I am going to give the input voltage, the designed value will be 5 volt. So I am going to set the voltage at the DC regulated power supply to 11.25. I set my input voltage to 11.25. So next I am going to control the regulation by using the plot. So see here, the output voltage will be 4.82. So I am going to plot the graph based upon the output voltage and the input current measured. So I am going to regulate the current. By changing the current also, the output voltage will be the constant. So I am going to change the from 4 point something value, 4.67, 8, 9, 5.2 also, the current will be 4.82. Further increases some 6.8, 9, for 6.9 also 4.82. Again you increase, is a final. So increase up to 15.6. The the voltage will be 4.8 only. So by varying the current also, the output voltage will be the constant. So we can plot the graph based upon the voltage we adjusted versus voltage we adjusted as an input, and the current versus voltage we need to plot. So if you plot the graph, it will comes at constant voltage at the starting position some 4.8. It will be constant throughout the variation in the current. So this will gives the line regulation of the IC723. So hence our IC723 is working for both load regulation as well as a line regulation. So this completes the experiment of line regulation and load regulation using an IC723.
At MSR UAS, we spark your imagination unlike any other.